Okay, next up we want to find the value of c that is going to make what we have into a perfect square. So for perfect squares, let's just think about what those are, just in case you don't know. So for the perfect square method, if I have x by x multiplied by bx yeah, so if I have x by x multiplied by bx, I can turn it into almost a perfect square, which is where that name comes from. If I just multiply these two, I'd get xb by x, and that isn't a perfect square. But I can make it nearly a perfect square if I divide this b in half, this bx in half, and add each half one horizontally and one vertically. And so what that means is I will now have this and a little bit and a little bit on the other side too. And so almost a perfect square. And so what I'm going to be missing, I have x b over 2, x b over 2. And so I can see that it's almost a perfect square, but what I'm going to be missing here is going to be a square of b over 2 by b over 2, which is b squared over 2 squared. Now, this is just the visual representation. What's actually happening is based off of the fact that x plus a squared, a perfect square, is going to be equal to x squared plus 2ax plus a squared. And so this a squared is what I'm looking for in this case. And so I have x squared plus 5x plus c, which means 2ax is equal to 5x. You can cancel out both 5s. I have 2a is equal to 5, which means a is equal to 5 over 2. b over 2. And so that means a squared is going to be b over 2 squared, so 5 squared over 2 squared, and that's 10 over 4. So in my question, c is going to be 10 over 4. So the reason why you have b in this and 2ax here is just based off of the fact that standard quadratic form is ax plus bx plus c. And so in your c position, you would have b over 2 squared, because b would be 2a, and a squared is b over 2 squared. And so I hope that all makes sense for you. But your final answer should be 10 over 4. Oh, sorry, 25 over 4, not 10, because it is squared.